Here's another problem dealing with an angle of elevation. A flagpole that is 14 meters tall casts a shadow 10 meters long. Find the angle of elevation of the sun to the nearest degree. Let's draw a quick sketch. We're going to have a flagpole, and we know that that flagpole casts a shadow. So we're going to draw a length, which would be along the ground, and we have some information about these lengths. We know that we have 14 meters, and we have a shadow that is going to be 10 meters. Now, since the shadow is going out in this direction, that means that I've positioned the sun over here to the left. It's going to cast a shadow by hitting the top of the flagpole, and then that's going to direct the shadow downward. Now, be careful and make sure you put the shadow on the ground, not as the length of the hypotenuse here. The shadow's not up in the air somewhere. So what we're trying to find is the angle of elevation. That's going to be the angle formed with the horizon looking up toward the sun. In other words, we're looking for this angle that's marked here. Let's just use the letter A to stand for that angle. Now we have a relationship between an angle, a side opposite, and a side adjacent that we're going to try to find. We can use our tangent function in order to get that. We'll set up the equation where the tangent of A is equal to 14 meters divided by 10 meters. I've dropped the unit. And now to solve for A, we're going to, well, let's go ahead and do one more thing here. Let's go ahead and take 14 and divide by 10. That'd be 1.4. To solve for A, we're going to use what's called the inverse tangent. That is, A is going to equal the inverse tangent of 1.4. Think about you always using inverse operations, and so if we're now starting off taking the tangent of A, then we use the inverse tangent in order to get A by itself. We can use a calculator in order to come up with this approximation, and we come up with A approximately equal to 54 degrees in this problem.